My name is Dr. Parada, and I will be discussing the spectroscopy of simple molecules. The objective of this experiment was to identify unknown compounds using spectroscopic techniques. To identify the unknown compounds, we used methods of infrared spectroscopy, known as IR, and nuclear magnetic resonance spectroscopy, known as NMR. IR and NMR work with similar principles according to the Chemistry 120 Laboratory Manual. In the IR technique, the absorbency of a photon in the infrared region leads to an increase in the energy of a molecular vibration. This is most useful in determining if functional groups are present. This information is displayed on a chart in which if the vibrations are detected as a peak presented on the chart. Each functional group absorbs a different IR frequency. Figure 1 is a chart representing each functional group and their associated IR absorbency ranges. In the NMR technique, the absorption of a photon in the radio frequency region leads to an excitation of a proton in the nucleus. The absorption peaks of each chemically different hydrogen atom will appear in different frequencies on the radio region. The area of each peak is directly proportional to the number of hydrogens of that type. This technique provides two pieces of information: how many different kinds of hydrogen atoms are present and the number of each type of hydrogen atom. Both figures 2 and 3 display the potential unknown molecules used in this experiment. In figure 2, the X's indicate which functional groups were found using the infrared spectroscope. Figure 3 displays the number of peaks and the ratios found in each potential unknown molecule using the NMR. I was given 3 unknown molecules, named F, A, and M, number 48. In figure 4, the X's indicate which functional groups were found in each IR graph. Figure 5 shows the amount of peaks found in the NMR graphs as well as the ratios of the different types of hydrogens. As you can see, molecule F has 2 peaks in the CH benzene ring and the CH singly bonded carbon. And molecule A has 2 peaks in the OH region and the CH singly bonded region. And molecule M has 2 peaks in the CH singly bonded region and the CBr region. For example, this is an NMR graph for molecule F. It shows 2 peaks, meaning there are 2 different types of hydrogens, and a 2:3 ratio, meaning there are 2 types of one type of hydrogen and 3 of another type of hydrogen. The IR chart for molecule F shows peaks in the CH benzene ring absorbency range as well as the singly bonded CH range. Referring back to figures 2 and 3, this narrowed the possibilities to only the compounds with the CH benzene ring, which are those 3. After analyzing the NMR graph, which showed 2 peaks in the 2:3 ratio, the only possible compound was paraxylene. This is a picture of the paraxylene compound. As you can see, the CH benzene ring functional group is present, as well as the CH functional group. The IR chart for unknown compound A shows peaks in the singly bonded CH absorbency range, as well as the OH absorbency range. Narrowing it down to these 4 options. After analyzing the NMR graph, which shows 2 peaks in the 1:3 ratio, the only possible compound was methanol. This is the methanol compound, and it shows the CH carbon functional group and the OH functional group. The IR graph for unknown compound M shows peaks in the singly bonded CH absorbency range, as well as the CBr range. Narrowing it down to these 4 options. After analyzing the NMR graph, which showed 2 peaks in the 1:3 ratio, the only possible compound was dibromomethylpropane. This is a dibromomethylpropane compound. This is its singly bonded CH functional group and the CBr functional group. After doing some research, I found that methanol was the most commonly used compound out of the unknown compounds I was given. Methanol is the simplest alcohol and is produced naturally in the anaerobic metabolism of a variety of bacteria. Other than being naturally produced, it is in thousands of products that touch our daily lives. According to methanol.org, here are a few examples that are made from methanol. In conclusion, with the help of the infrared spectroscopy and nuclear resonance spectroscopy, I was able to easily figure out and explain which functional groups were present in each unknown compound, as well as the different hydrogen atoms and the number of each type of hydrogen present in the unknown compounds, therefore making it possible to identify which compounds I was given.